Trig integrals part 2, sines and cosines continued. We're going to look at integrals that use either sine squared x or cosine squared x. To integrate either of these, we need to use a trig identity. That is, we can rewrite sine squared x as 1/2 minus 1/2 cosine of 2x. And we can rewrite cosine squared x as 1/2 plus 1/2 cosine 2x. Without going through the details, but just a brief reminder from trig, cosine squared x minus sine squared x equals the cosine of 2x. It's one of your double angle identities. And then using the Pythagorean identity, sine squared plus cosine squared equals 1, and a little bit of manipulation, you can get those two up there. So let's simply integrate the cosine squared of x. This occurs a lot, for example, when you're doing polar areas. You might end up with cosine squared or sine squared. But to be able to integrate this one, we would need to use the above identity. Cosine squared equals 1/2 plus 1/2 cosine of 2x. Then we can find the antiderivatives. The integral of 1/2 is 1/2 x. The integral of 1/2 cosine 2x is 1/4 the sine of 2x. That is a u substitution problem with u equals 2x if you want to go through the work. And then plus our constant of integration. What if, instead, we had something like the sine to the 4th of x? This integral is going to get just a little bit messy. Before we can find the antiderivative, we will need to rewrite the integrand a few times, I would say. I would start by rewriting, or at least thinking of it as being sine squared times sine squared. And then each of those needs to be rewritten as 1/2 minus 1/2 cosine 2x. Now, we need to distribute or multiply both of these things. So I get 1/2 times 1/2, and then show you what I'm doing. If I do this one multiplied, and then this one multiplied, you would get negative 1/4 cosine 2x twice. Plus 1/4 the cosine squared of 2x. Well, now I have another problem here. Before I find its antiderivative, I would need to rewrite that one. So I will rewrite the entire thing. 1/4 minus 1/2 cosine 2x plus 1/4. And then this back piece here becomes 1/2 plus 1/2 the cosine of 2 times 2x. So let me clean this up just a little bit one more time before I find an antiderivative. I would have 1/4 from there and then 1/8 from here, which will give me 3/8. Remember, this is not the antiderivative, I'm just rewriting the integrand. Then I'll have minus 1/2 the cosine of 2x. And then I'll distribute this back part, which will give me plus 1/8 the cosine of 4x. And it takes all that work just to get to a place where we can find the antiderivatives relatively easily. So finding the integral with the antiderivatives, we get 3/8 x minus 1/4 the sine of 2x plus 1/32 the sine of 4x plus c, and again, to get this constant here and this constant here, we would be doing u sub on those parts of the integral.